Right, you've seen the packs, how they're going to be wired in. You've seen how the relays are going to change over from serial to parallel. You've seen the charging unit we're using and how each pack is going to be fed through the diodes and then through the relays once they've been switched over. I've showed you how we're going to be wiring the relay coils. They'll be in parallel. And now, with the help of the LM3914 monitor, I'm going to show you how we're going to switch these relay coils on and keep them on during the charging cycle. Okay, first of all, it comes off a control voltage which is totally separate to the output voltage of the lithium ion cells. Now, when the LM3914 is looking at a full battery, it'll be at 12.6 and the 12.6 LED will be switched on. It'll be grounded. Now, as we use the charge and it drops down eventually to 10.6, it will then switch this LED on, taking that to ground. And then we're going to take that grounding point through 1N4007 to switch on a PNP transistor to energize this coil. But there's a transistor in the way, another PNP. Now that PNP needs to be on when that transistor comes on in order to complete the flow to ground and energize the relay. So to do that, we ground it with a 100k resistor, switching it permanently on. With it being permanently on, we've only then got to worry about the signal coming from the LM3914 to switch this one on, which then switches the relay on. It closes its own pair of contacts to keep the flow going to the relay. And then that will maintain a positive voltage out to the relay coils to keep them on during the charge cycle. And once the charge is reached 4.2 on each set of cells, then this transistor will be switched off, dropping the relay out, dropping the latch out, taking the voltage off the relays and putting everything back to normal. Now, how we switch that off is in the next bit. We use a 3 transistor, what we call AND gate. So you need 1 and 2 and 3 on before you can switch this transistor on, off, and drop in the relay out. Now I expect some of you are wondering, why are these diodes in backwards across the coils? The reason for that is, when you de-energize any coil, the magnetic field around it collapses down onto the coil and induces a current into the coil, which can damage transistors, ICs, and do other nasty things to the components. So we put those in, which basically puts a short onto the back EMF because it's coming from the opposite direction, and it doesn't affect anything because we made it short, shorted it out. Okay, so to recap, when the LM3914 sees 10.6 volts on the cells, through the resistor, through the LM3914, this LED is switched on by grounding this point here. When that point goes to ground, so will this diode go to ground, which will then pull through this resistor the base of this transistor down to ground, switching it on. It won't be completely at ground because of the two series resistors coming from the positive rail, but it'll be low enough to switch the transistor on. Once the transistor is switched on, it puts positive volts onto the top of the relay, which is already grounded through TR5, and energizes its contacts across the transistor to maintain that latch, which then maintains a positive feed out to the relays and keeps them energized during the charging cycle. Why do we want to keep this latched? Because this transistor will eventually, as the voltage rises, that LED will go out, so there will be positive volts on there, and because there's positive volts on there, there will be positive volts on the base, which will switch it off. So we want to make sure that we've still got a continuing circuit to feed the changeover relays, and that's how we're doing it. Okay peeps,